Hey, at this time, we are going to take a look at a little bit more about implementation. The term implementation here means computer software implementation using computer languages. Before doing that, if I assume you are kind of novice programmers or even totally new to computer programming languages or something, that's fine. Let's get started from the bottom level, higher level description. Okay, we are going to take a look at some computer language issues for your actual implementation, and I'm going to show you some examples and description with some case study. Okay, so what is computer language? Let me turn off my face. Computer language simply means a communication tool with computers. So if you want to control your computer, if you want to do something with the computer, you need to do something for communication skill, right? Communication tool with computers. That is computer programming language. Okay, this is communication tool with computers. So let's take a look at, as we reviewed this one before, this is the TIOB Programming Community Index. As far as 2020, the most popular language here, Java, right? Java. And the second top is C, and the third one, Python, right? Python. So I'm 100% sure that you may be heard of a C language, or sometimes C++ language, or C# language. Okay, C# is one of the .NET language. C#, C++, C, they are all kind of C family, and at least you heard about Java. And nowadays, the most popular language is kind of Python. So these languages are your subject to train yourself to learn. But actually there are something more. So let's quickly take a look at this hierarchy example. Okay, as you see here, this is computer hardware, and here is anyway your language. Okay, actually something in between. Okay, controlling your hardware. On top of computer, there is machine language and assembly language. Actually, those two languages are so-called low level. Okay, low level language. What is a low level? In low level language, they all can be described in this form: 0, 1, 1, 0, 1, 1, 0, 0, 0, 1, 1, 1, 0, blah blah. Everything in digit. You know what is digit? Digit means on or off. It's kind of Boolean. On or off, 0 or 1, yes or no. Okay, it's a kind of Boolean. Why? Computer only understands this kind of signal. Okay, so we need to convert. Okay, for example, you say hello here. Human language hello can be recognized by anyone, right? You can understand hello. Okay, there is some different countries, different mother tongue issues, but neglected. Okay, anyway, and you say hello, human can understand it, right? Okay, but how about computers? Computers cannot understand what you are saying, so you have to interpret this hello to 0, 0, 1, 1, 0, 0, 1, 1. I'm not sure what it is in bytecode in digital representation, but anyway, something should be interpreted in this way. So certain type of computer language module, so-called interpreter, or sometimes we say it compiler. Okay, these things in charge of interpreting, translating your word, human word, into computer word. Okay, so when you are saying or learning computer language, any type of computer languages have their own interpreter or compiler in order to turn your command, your language, human language, into this kind of computer language. So this is how this one is working. Okay, actually there are something even more lower level, even lower level of computer hardware thing, and even higher level of this kind of computer language thing. So let's take a look at a little bit more about it using Google's. Okay, let me take a look. Computer language hierarchy, like this way. Take a look this kind of image. Okay, if we take a look at this one, I showed you this one. Okay, how about this one? Let's take a look. This one explains you even lower level of the computer language. Okay, let me copy this one to here and let me show you. Even lower level of computer hardware, there is something. Okay, now we see compiler, something important thing, and we found operating system. What is this? This is Windows or Mac OS, Macintosh operating system, or iOS for iPhone or iPad, or there is, that Android for your Android phone operating system, Windows for your laptop or PCs, iOS for iPhone, and so on. There are some more operating systems. Anyway, virtual machine assembler, computer architecture, ALU, blah blah. Okay, take a look. Here is another important thing: arithmetic, logic unit. This one is something about CPU. Okay, central processing unit, and computer memory, Boolean logic. This one always I told you 0101, 0011, whatever. So very low level. Okay, and applications. For example, Chrome, Rabbit, SketchUp. All these are computer applications on top of operating system and the compiler, virtual machine, assembler, computer architecture, blah blah. Very low level. We don't need to talk about, or we don't need to deeply look at this part. Okay, my point actually here is this part. Some higher level of this, some higher level of this part. Okay, just a second. So if we have this level of some higher level, language level, what we need to do is something higher level issues. That's what we need to talk about, because the lower level things are sort of computer science or computer engineering issues. What we need to do is something higher level. We need to understand the mechanism, how these kind of programming languages are working, and take advantages of existing tools for programming. Not just for programs, for programming. So think about this. Computer programming language, for example, Java, C, C++, C#, Python, those computer languages can be used for programmings. Program for programming. This is very important. What we need to use is computer programs for computer programming. Okay, that's my point. So what we need to do now is take a look at some mechanisms in this higher level things. Okay, in this structure, as I mentioned before, some low level thing, some low level issues, that's not our topic. Okay, we need to take a look at some higher level issues. As I told you before, Fortran, C, Pascal, Java, object orientation, or some visual languages, they are sort of higher level, but let's take a look at what are in even higher level of this one. Okay, for example, I told you interpreter or compiler. So if you program or learn Java, Java should be compiled, and then compiler going to be turned into this kind of machine language in order to running on top of your machine, Java. Okay, but if you use Python, Python needs Python interpreter. So this one going to be interpreting a certain set of computer languages and then compiled and running. Okay, or what if you use HTML? You may heard about this language HTML. Interpreter also used for HTML for interpreting this web language, hypertext markup language, or XML or other type of languages can be interpreted by using for computer hardware. So nowadays, this kind of interpreting language is very, very common. Before that, it's kind of the sort of last language, or C# language also need to be compiled. Okay, they should be compiled before running, and then they're going to be run. But Python, HTML, you know, HTML can be run on top of Chrome or Internet Explorer, simply because they can be easily interpreted by interpreter, certain set of interpreters, okay, and then quickly learn. These are very, very high level language. I recommend you to learn and to use this kind of high level language, interpreting language, okay, because they are very easy to learn. Learning language is simply say learning syntax, but syntax is very easy compared to those languages, or Java or C#. They are kind of intermediate, or we can say they are hard to learn syntax, but these languages are very easy syntax, and they can be quickly and easily interpreted. Okay, that's the reason why I take a look and saying about these languages. Nowadays there are a lot of easy to use languages. Let me quickly draw this kind of thing. This is your computer, laptop, or operating system, or PC, whatever it is. This is the target you wanna working on, right? So there should be kind of compiler or interpreter in order to translate your language into computer languages, so that your implementation, your computer software is running on top of your machine. Anyway, something is here, but we don't need to take a look at this one in detail. There are something something more here. Simply we can say that they are kind of platform. Let's regard this one as a platform. And there are something more, APIs, okay, APIs. Or we can say that libraries. So we don't need to take a look at this part, hardware part or interpreter compiler part or something. What we need to do is very high level things like this one. What's the example of this platform? Sometimes this one can be Rabbit, okay, or sometimes this one can be Python environment. What is API? What is a library? These are some Rabbit specific, for example, Rabbit API, we can say that, or this one can be some sort of Python library set or Python utility set or some Anaconda or some other type of things you can use. So what's REST? Even higher level of this one is your language, your input language. This one can be Python or sometimes Java, but it's not recommended. Python is recommended, or C# as a Rabbit API language, or web languages, for example HTML, XML, and so on. Okay, so even this low level, there are many things that I show you today, the diagram before, but anyway, some higher level things, that's what you need to take a look at. You have to dig into this kind of high level things and then you can develop something. That is why I introduced you this one before, major feasible approaches. For application development, my recommendation is here, C# language, Java language, or Python language. The last option is sort of web languages. So those two languages are interpreting languages, and this is compile language. Those two are compile languages, compile, and these are interpreting. Anyway, those languages are your feasible options to learn. Okay, simply say C# is good for Rabbit plugin development or other application development. Python, good for general, very powerful nowadays, and web language for web applications. Okay, so these are my recommended computer languages to learn. Additionally, database. These are some database server, and these are web languages for web app implementation. But I told you before, some WordPress, Wikimedia, some web contents management system. Web contents management system is very powerful manager mode in order to set up your web system. For doing this, you need sort of database. Of course, these one already provide very well developed, well designed database. What you need to do is your data, manipulate your data, processing your data, and try to make your own domain specific thing. That's what you need to do. The last option is, I told you before, anything, any other available tools you can use. But for your convenience and some kind of feasible means you anyhow you develop what you planned in this master. So these are my recommendation for your development. Okay, C# is very good for and powerful for Rabbit plugin development, Rabbit plugin. Okay, and Python for general things and some machine learning things or whatever. Web for your web application development. So these two are interpreting language, and this one compile language. Additionally, if you have interest, take a look Java. Okay, that's possible. But those two are compiled language. That's what I told you before. Let's quickly take a look at one example. Processing. Actually, it is a script language based design approach, but actually this one is exactly same syntax to Java or C#. Very close to Java or C#. Okay. As I showed you before, if this is processing code, and take a look, this is Java code. So this script translation into Java kind of sort of long, but this is formal Java language, that's why. And this one can be compiled to Java virtual machine, and running result is here. What you need to learn is this part. Take a look. Compared to this Java, this script language processing looking much easier. Okay, this is processing language. You need to download processing and install it. This is processing.org website. You need to download processing language, the current version, and try to make this one running, okay, for your training, and take a look about some scripting language things. Let's take a look this example. This is processing test, and this is processing window, okay. Integer D P1 through P4 defined like this way, and size means the window size and some configuration for window, and draw gray box, draw white points. Take a look. White points and rectangle shape consist of 4 lines like this way. Okay, so this is kind of very easy and beginners code. Anyway, you can write down this kind of code in processing window, and you can make this one as a result window. Take a look. This is another example. As you see here, something complicated, but this is the syntax you need to learn. For in C language or Java language, this is loop, okay, iteration. This is the iteration condition, and this one is very short, but thanks to this loop, result can be displayed like this design, this visualization, this geometry. Let me open the processing language. I downloaded the processing, and let me show you the processing example here. You can easily download this one free and take a look this one for your training. Processing language is very good for beginners programming training. Okay, this is empty, and let me copy this example to this one. Okay, instead of typing one line by line, I quickly copy and paste this example. As you see, this processing language tool looks very simple editor. Let me click this one, run, and let's take a look what happened. This is output result window. As you see, the circle shape varied by different radius, and bigger one, bigger white, and smaller white, and then filled with black color like this way. Let me take a look at this one. What if I change this one, the size, to using my mouse? As you see, the 2 slash means the rest of line, it's in gray color because this one means comment. So disable entire line because of these 2 slash. This is C language style, okay? So I just changed size from this fixed number to this one, mouse X, mouse Y. In processing, the keyword mouse X means the value of X of your mouse location, cursor location. In the same way, mouse Y means your value of y value of your current mouse cursor location. That means if you move your mouse X, mouse Y value going to be changed. So the size of the circle going to be changed by your location of the mouse. Let's take a look at, if I learn this one, as you see, if I move the mouse, the size of the circle going to be changed like this way, okay? In the same way, if I change the size, okay, if I change the size to 500 and 300, smaller size window, and if I learn, the result window going to be changed like this way, the smaller window, right? So let me go back, 1000 by 600, and then the result window going to be back in this way. So this is very easy and quick example of your processing language. Anyway, processing is very good tool for training and learning computer programming language for designers who major design or who majored architecture, inter-architecture, like us, okay, like you. So even if this is very beginner's language, I believe in this is very good tool, powerful tool for training for your computer languages, okay? So the output result is here as an example. Next is visual language based approach. As I showed you before, this one explains this one. This is the current representation about computer programming language in text, right? A is a set, B is a static number, result R is an array of A minus B, which means this set minus 5, something like that, okay? As you see here, set A, set B, 6, 7, 8, 12, and 5, and result means total A minus B. So 6 minus 5, 1, 2 minus 5, 2, 7 minus 5, 2, 8 minus 5, 3, 12 minus 5, 7. So result R returns 1, 2, 3, 7, like this way. So this is visual representation of this structure, okay? This is input A, right? And this is input B. A is array of those three numbers, and B is static number 5. Result also going to be array, but it has operation. It's a function, okay? Function fx is set A minus set B. This is the visual representation of this program, okay? Even some complicated function is here, but anyway, result can be represented in this way, like this way. So you can take a look this one without confusion, I believe. So the power of visual language is, if you write down in text programming, sometimes it's not that easy to figure out. It's not intuitive, but this visual representation is very intuitive and easy to recognize, easy to understand. That's the point. So nowadays we are working with this kind of visual language. So in the perspective of interpretation compiler, what's the role of this one? There is another interpretation, another interpreter. So that interpreter is in charge of interpreting to code. For example, Python code, Java code, whatever, okay? And then this one going to be compiled, okay? Using some specific compiler, and then they going to be compiled, and then hardware, so that this one is running on top of your machine. So if you learn Python, Java, they have some type of interpreter or compiler in order to working on top of computer hardware. But another layer, another level, this kind of visual language can be interpreted into text language. How about processing? We saw this one, processing. Processing is interpreted into Java language and then compiled. So my point here is these are higher level languages. What you need to do is take advantages of those higher level languages. Okay, take advantages. That's my point. Okay. Take a look this Rhino grasshopper example. As you know, this kind of grasshopper result can be generated by this nodes and some visual language based inputs. So this kind of visual grasshopper example can be interpreted using certain type of interpreting language, interpreter machine, and then interpreted some text language. I'm not sure what it is, but anyway, this one can be interpreted into a certain set of text. Okay, this text can be Python, C#, Java, or any other languages. I'm not sure what's the lower level language of grasshopper, but anyway, this visual language is very popular because much easier than this kind of text language. So interpreting language in charge of interpreting this visual representation into text language. That is why this is kind of popular visual language in current development. But in someday, probably entire programmers going to use this kind of visual language instead of using this text-based language. Why? They are easier and powerful, but same performance. Very powerful and can be compiled and running on any other languages. That is why I'm saying this is kind of sort of future languages and so on. So Dynamo on top of Rabbit. In the BIM class or some design class, I always mention Dynamo and encourage students to use this one for their parametric design or something, because this kind of node-based graphical representation much intuitive and powerful, but still working the same as C# language or some Rabbit API things or something. So Dynamo going to be interpreted to C# language or something. I'm not sure what it is. Probably Visual Basic.net, but let's assume that this is C#. But interpreter is in charge of converting this Dynamo visual representation into complicated C# language in order to running on top of Rabbit. Okay, so that's why this kind of Dynamo can be popularly used to even to novice programmers and so on. Let's take a look some Python example. Okay, Python, let me type Python. Actually, I'm a Java programmer. I'm not sure about Python. I'm totally new to Python, but at least I know Python is very powerful and very popular, very popular language nowadays. As you see, Python is an interpreted high-level general purpose programming language. This is one single line definition about Python. As you see, this is an interpretation language, script language, okay, and high-level language, and general purpose programming language. That means if you take a look at Python as your first programming language, This one going to be very useful for your further development and your software implementation in the project. Okay. Let me introduce you one example, case study and demonstration using Arduino. It's a processing like script language based upon Java. But at this time, this example used Rhino, Grasshopper, visual language as well, as I introduced you before. So let's take a look at this case study quickly. At first level, this simply shows you an inquiry to implement an integrated process of several texts for visualizing. Okay, let's take a look. Visualization on environmental building data. Actually, this term looks kind of bigger, but simply say, I think this one is better. Let's take a look. This is Rhino, and here is a floor plan. Okay, actually very small sized office, research lab office example, and some kind of visualization. What's this? This kind of reddish yellow colored or bluish colored, but it's 3D. Okay, overlay. Actually, this the kind of thick yellow color means kind of higher temperature, and blue color means lower temperature. But this is too simple. Just measure the temperature and visualize them. It's too much simple, right? Actual intention is this is kind of sudden change of the temperature. Okay, sudden change of the temperature in higher bound, which means actually this is the radiator and the built-in radiator as well. So thanks to this one, the temperature of this indoor office can be rise up in this area. Okay, if we turn off this radiator or some ventilation for heating, the sudden change of the temperature going to be going down. Temperature is going down. So the ratio of this kind of axis, z direction, plus direction, and minus direction, this means sudden change of the temperature, the amount of the change can be visualized like this way, this colored thing. Okay, so this environmental data is actually very simple data, just temperature. But this diagram visualizes the sudden change of the temperature in two directions, plus direction and minus bound in both. So as you see, the input data can be sensor data. Okay, thanks to Arduino temperature sensor, we can collect the temperature by second, by minutes, by 20 seconds, by 5 minutes, and so on. So data collection module in charge of the turning the sensors numbers into structured data. I mean, some kind of structured data structure we need. And there is another processing module. This one in charge of convert the structured data so that they can be used for visualization of the sudden temperature change or something. And another data part is building model part. Existing floor plan, right? Floor plan, like this one, existing building data. And another one, visualization part. So visualization module in charge of this kind of sudden change. So take a look, input part can be transformed into this one, transformed into this one. Okay, numbers here from sensors can be changed into this kind of colored visualization using those input numbers, using what? Rhino and Grasshopper. Okay, and then they can be final representation can be visualized on top of Rhino. So this one in charge of handling just the existing floor plans, right? This one, and input numbers going to affect the changes of this color gradation, color visualization on top of floor plan. So this is the kind of data structure diagram, okay? Existing building floor plan, input data from sensors, and building model can be visualized all together, and then final visualization can be here. So that's why I showed you before. So take a look. Building model, input data part, building model part, input data part, and visualization part, they're going to be integrated into one single visualization. So that's what I explained to you in former slide, and this is kind of specific and more detailed module representation. Arduino Uno, and this is the sensor name, and Arduino language coding going to use this one, data collection and data processing, and they can be used like this way. Something elaborated one from this formal one. So as you see, Arduino board and the sensors, and our example and our sensor here, temperature and humidity sensor, just $10 amount, okay? This one can be used for this kind of data collection. So take a look data structure here. What kind of data collected? At first, time. Next one is temperature. And actually we didn't use humidity in the visualization, but anyway, humidity data can be found. Anyway, time, temperature, humidity, just 3 columns, and take a look. Time, it's 10-second based, 10-second based collection, and amount of data can be collected, and they all written on top of the Microsoft Excel format, okay, like this way. So data acquisition for Excel, this one is the one we used, data acquisition module, the PLX DAQ module. This is another plugin software for Excel. Anyway, this one used for data processing based upon this data collection. So this is the simplified data structure for this one. And as I showed you before, the data structure for entire system can be described like this way. Okay, this is the entire data structure. Existing floor plan, building model part, and input data part, and visualization part. There are many sub-data structure in each module. Okay. So thanks to this input data structure, we can reuse this data into using this Excel module, and then they can be loaded into Grasshopper. Okay. So far this is Excel, but before this, sensor is here. So sensor data can be loaded into Excel datasheet, and then another Excel module can be transformed this one into Grasshopper thing. So how many objects, how many entities, even in this simple data flow, sensor, Excel, and the Excel plugin I showed you before, some kind of processing, and Grasshopper. At the end, this one going to be visualized on top of Rhino, right? And external data as well. External data. What is that? That is AutoCAD DWG file, floor plan. Okay, this one going to be loaded as well on top of Rhino. So final visualization can be implemented on top of Rhino. As you see, this is input the Rhino based AutoCAD floor plan file, and some description about this one, and take a look, the sensors placed in these places. Actually that was a mobile, can be connected to the laptop and collect the data set like this way. And take a look, radiator and the heater as well. So 2 heaters and kind of built-in heater and infrared heater and radiator. So window is here, door is here, so they can be some kind of triggers for sudden temperature change, as well as those 3 heaters. Anyway, as anticipated, our visualization can be resulted in this kind of visualization. I show you this one before. So good thing from this kind of visualization is kind of where's going to be sudden temperature up or sudden temperature change to the lower degree, something like that can be. Actually, this is very simple example. We can anticipate how this temperature change can be changed because of this the actors. I mean some triggers. Okay, those heaters or some cold air suppliers like windows or doors. We can anticipate this one, but the point here is our plan is sudden temperature changes can be anyhow visualized in this 3D way on top of this existing 2D floor plan, and they can be used for further applications or some kind of weather data, indoor microclimate, micro temperature changes, anticipation, or their applications for environmental things, whatever. Okay, so the scope of this one is visualization, but anyway, there are many inputs, many intermediate modules, and the final visualization module as well. So sort of well-defined some scopes and well-defined modules and implementation plan, and then the final paper can be published like this way. So that's why I show you this one as an example. Okay, let me tell you some assignments for next week. Assignment 3 is processing. So you need to install processing on your computer at first and try to find out a good example and turn it into your new one. This is actually the totally kind of shortcut to use processing, but just for your information and just for your convenience, I can tell you this is one easy way to find out how to use this kind of language for your further development as a kind of first coding example, and show me 2 original and yours demos. If you program a new one, just one. Okay, I encourage you to try to program your own visualization, own graphical representation using processing, totally new one. But anyway, try to find out a lot of examples using processing website. In your processing website, you can find out examples. If you click any of those examples, if you click, you can find out this kind of examples. And this processing code is here, and you can simply copy and paste, and you can use this example. My expectation is not this kind of too much and very easy example. Okay, instead try to find out your data and your algorithm structure, and then just take advantages of this existing very good powerful scripting approach using processing. So that is why I got you an example assignment using processing. That's the assignment 3, and here is the assignment 4 as an extension of your thing you are now working on, your development plan. Next week we are going to have a live meeting, live class by using Zoom. Okay, I'm gonna let you know about that Zoom live class for your development plan review and so on. Anyway, for your development, this assignment is something getting deeper, okay, for data structure and algorithms. Last time I introduced you, computer program simply means data structure and algorithm. So according to your development plan, list up all data you need. One data set could be one entity. So their relation can be described. Try to describe them, how they work each other. Visualize series of your input, process, and output structure. And try to draw diagrams so that you can see your data structure and algorithms. I'm gonna let you know and comments using some actual conceptual modeling approach for actual implementation, actual development next week. But right now, try to list up your data. Try to list up all data set you need for your implementation. Okay, so if your data is, for example, is human data, this is your data, your entity, and you can describe about this one. For example, properties, age, and birth date, birth year, birth date, and hair color, or something more. This is properties, okay, and this is entity, or we can say this one is object. Anyway, this is data structure. So try to find out how many data you need. Okay, this is the kind of even without experience, you can figure out what kind of data structure you need. So data structure you can try to find out, and algorithms means how to manipulate your data. Something existing data, something derived external data, something can be manipulated or newly generated data in your process. Whatever it is, try to elaborate your plan using your data. I'm not talking about your actual data, okay? I'm talking about your data and its structure. Even you don't have any experiences to describe this one, try to find out anyhow your data things. Okay, this is the your assignment for this week, and we're gonna have a live class next time. Okay, that's it for today. Okay, thank you.